All right, skill 13, solving a system of linear inequalities by graphing. The issue here is that you have two inequalities. Both of them have points that are solutions. You want to figure out where the points are that are solutions for both inequalities, and a nice way to do that is by graphing, because there's many solutions that work for both inequalities and a graph shows them easily. So like graphing single linear inequalities, you want to graph, these are easier done just by graphing by intercepts and then decide the boundary line and some shading. So you want to combine that shading part to one solid area that represents a solution. So for the first one, 3x minus 4y is less than or equal to negative 12. I first want to graph this as a linear equality and just try to figure out the boundary line and where the solutions are for this first problem. So I write it as 3x minus 4y equals negative 12. I make an xy table and I just want to find intercepts and graph that boundary line. So if x is 0, this term goes to 0, so 3 times negative 4 gives me negative 12, so that's going to be a 3. If y is 0, this whole term goes to 0, and 3 times a negative 4 will give me negative 12, so that's going to be here. So that's 2 points for that boundary line. So here is 0, 3, and here is negative 4, 0. Because it's less than or equal to, the equal to part says that this boundary line is going to be solid, so points on the line are solution, as are points on either above or below that line. Now to decide where the solution is on which side of that boundary line, I want to just check a point, and the easy point to check is 0, 0. So I'm going to go through and check that point 0, 0 and see if this point 0, 0 is a solution. If that point works, I'll shade that side. If not, it's the other side. So if I put in x equals 0 and y equals 0, I get 3 times 0 minus 4 times 0 is less than or equal to negative 12. 3 times 0 and 4 times 0 is all 0 minus 0 is 0. So this ends up being 0 is less than or equal to negative 12. That is not true. So that means that because 0, 0 isn't a solution, all the points on this side of that boundary line are not solutions. So the points up here work. I don't want to shade all this. It'll look a little bit messy and hard to read near the end. I'm just going to make a little mark up here that says I'm going to shade this side of that boundary line. For the second problem, same thing. Go through, figure out the boundary line, and then decide where we shade. So I rewrite it as 5x minus y is equal to negative 5. I make an xy table, put in the zeros for x and y. If x is 0, this whole term goes to 0, so the opposite of y equals negative 5, so y is 5. If y is 0, this whole term goes to 0, and 5 times a negative 1 would give me negative 5, so this is a negative 1. So those are my two intercepts, so I have 0, 5, and I have negative 1, 0. And it's greater than or equal to. The equal to part says it's going to be a solid boundary line, so I connect those two. And this is the boundary line for the other linear inequality. I want to also decide, where do I shade on this line? Do I shade to the right or left? I'm going to check 0, 0 and see if that works as a solution for the original inequality, and then we'll combine that for the solution to the entire system, which is both inequalities together. So put in x is 0, y is 0. So 5 times 0 minus 0 is greater than or equal to negative 5. 5 times 0 is 0, minus 0 is 0. So I get 0 is greater than or equal to negative 5. That's true. 0 is bigger than negative 5. So that means 0, 0 works. So on this line, I'm going to shade this side of the boundary line because 0, 0 was a solution. So here's my solution. I have to shade all the points that are above this boundary line for the first inequality. So anything above here, but also anything to the right of this line. And where those two would overlap, if I go above here and to the right of here, would be any point that's in this place where these two lines kind of mark that off. So that's my solution. So any point in this area, called the feasible region, would be a solution to both inequalities. So that's how you solve a system of linear inequalities by graphing. So my solution, and the graph shows the solution of this. The graph is the important part. All right, here's an example for you to try. So go ahead, copy those problems down, graph it, and find the solution by graphing. Pause the video, do that work, and when you're done, turn the video back on and check your accuracy. All right, I'm assuming you went through and finished this problem. It's one problem that has two inequalities, That's why it's called a system of linear inequalities. I want to graph both of these together on the same grid. First, to graph this, I'm going to rewrite it as an equation and just graph that boundary line. So x plus y equals 5. So I rewrite it, x plus y equals 5, put in 0 for x, 0 for y. If x is 0, y has to be 5 to make this equal to 5. If y is 0, x has to be 5. So those are my two intercepts for that first boundary line. So here's that point 0, 5, and here's the point 5, 0. When I connect those 2 points together, the original inequality is less than. It's not equal to. When it's not equal to, that means that this line doesn't contain solutions. It's just like a fence that separates the solutions from the other points that are not solutions. So it's a dashed line, not a solid line. And if I check a point, I'll check a 0, 0. I want to see which side of that line do I shade on. So I'm going to check 0, 0 because it's not on any particular boundary line that I can see, and for this one anyway. And it's just easier to check out 0 and do the math and to pick some other numbers. So if I put in x is 0 and y is 0, 0 plus 0 is 0. 0 is less than 5. That's true. So that means all the points on the side of that boundary line where 0, 0 is will be solutions. So I'm going to pick the points down here. I'm going to put a little arrow. That means I'm going to shade this way at some point, but I want to put the other graph on the same grid and see where the shading overlaps. For the second one, I rewrite it as 4x plus 6y equals negative 12. And I'll graph that using intercepts. So I put in x is 0, y is 0. If I put in x is 0 right here, y has to be a negative 2 to make negative 12. If I put in y is 0, x has to be a negative 3 to get negative 12. So those are my two intercepts. So I have 0, negative 2, and negative 3, 0. The original inequality is greater than or equal to. The equal to part says the line is part of the solution along with other points. So it's going to be a solid line. Solid line means that points on the line are solutions. And now I want to check 0, 0 just to see where do I shade, which side of that boundary line. So I'm going to put in x is 0, y is 0 into the original problem. So I put in 4 times 0 plus 6 times 0, and I check to see is that greater than or equal to negative 12. 4 times 0 and 6 times 0 is 0. So is 0 greater than or equal to negative 12? Yes, 0, it's true. 0 is more than negative 12. So that means I'm going to shade above this line. So my solution to this system, which involves both inequalities, are all the points that are underneath this line and all the points that are on this line or above. And where those overlap are all the points that kind of hang out in between these two boundary lines. So I'm going to shade everything up here and everything below. And any point you would pick in this shaded region would be a solution to both inequalities, so therefore it's a solution to the system. So that is the end of skill number 13.